At any given time, there are millions of mechanical and chemical processes taking place across the globe. In industrial processes, for example, we use machines which require huge amounts of energy to power them. Yet, over 50% of the energy used in these processes is simply expelled as heat. Thankfully, Jeffrey Grossman, a professor of material science and engineering, has created an elegant and innovative solution to the problem of thermal energy storage. Grossman's solution revolves around the use of a phase change materials, or PCMS. A phase change material is one that absorbs energy as it changes state and releases that energy when it reverts to its original state. A common example is wax, which absorbs thermal energy as it melts and releases this energy, known as latent heat, as it solidifies. While PCMS already have a handful of useful applications, such as in heating systems, their usefulness is restricted by a major flaw: they are dependent on the temperature of their environment, so it isn't possible to control the release of energy using only PCMS. In order to efficiently utilize stored thermal energy, Grossman knew that he needed to create a mechanism which could trigger the release of latent heat on demand. He began looking back at old research, particularly his work on photoswitches. Photoswitches are molecules that react to light. Their shape changes when they are exposed to very specific wavelengths of light, and reverts when exposed to others. Although they couldn't store heat themselves, Grossman realized that by melting them together with PCMS, he could prevent the PCMS from solidifying at low temperatures, effectively trapping the energy inside. Then, by simply shining a special type of light on the material, he could cause the photoswitches to shift their orientation, allowing the PCM to solidify and therefore releasing the thermal energy it had absorbed. Grossman admits that there is still a long way to go in terms of creating practical applications for his idea, but so far it has shown a lot of promise.